All right, this time it works, I think. Okay, cool. I forgot to move the green screen in place. So, yeah, that was interesting. All right. Hey, everybody. Welcome to class today. Day 6. Technically, the 7th time we meet, but day 6 because day 0, we have a day 0. So, hello, everybody. All right. Let's go ahead and just get started then. How about that? So, today we're going to keep covering where we left off last time, which was we were talking about if statements. And then from there, we're going to talk about scoping within the usage of if statements and that kind of thing, and the concept of scoping in general. And then from there, we're going to go into formatting output, which is ways that you can make your output look prettier or nicer. Basic things like left and right justification, the kind of things you would do if you were writing an English paper. You know, you may want to have everything centered or to the right or to the left and so on. So those kind of things, basically. Before that, though, I'd like to take a minute to discuss the third assignment, since that one is due tomorrow night. And it's time to get going on that. So let me go ahead and just turn this one off. And there we go. Okay, so let me zoom in on this. All right, I think that's much better. So, by the way, we got, how many viewers do we have? It says we have 5 viewers. Is it we really have 5, or what does it say? Because sometimes it says a different thing here than it does on Twitch. I don't know. 13. Okay, half the class. That's actually the exact amount of people that voted for this time. So interesting. Okay, and I did see the TA's name pop up, I think, for a second there as well. Wasn't it? I thought it, I guess not. Maybe I imagined things. I thought I saw his name somewhere. But okay. So the third assignment is technically the third and fourth assignment. It's kind of combined. That's why there's no fourth assignment, because you're doing two. In reality, it's one big program, but it's two completely different things within the same program. And the only reason it's not just 2 separate assignments is because kind of want you to get used to the idea of a program being able to do more than one thing, you know? So if we had one program for every single task, we would just have an insane amount of programs, right? We use Firefox or Google Chrome to watch videos, to send the emails, to watch class, to read the news, right? We don't have individual programs to do that, like at some point in time may have been the case. Like, you know, back in the day, maybe it was not as common to watch a video directly on a browser. So you would download it and then watch it with Windows Media Player or QuickTime or VLC. Now you can do that, you know, inside of the browser. So we'd like to have the power of being able to have a program do multiple things. So here you have an example of your assignment where you have completely different things that your program is going to be doing, and yet it's all within one program. And so the first part is you have to make a calculator. And we still haven't learned loops yet. So your calculator only works once, and then you have to rerun the program. So kind of like a hand calculator in that sense, that, you know, you have to turn, I guess you don't really have to turn it back off and on because there is the reset button, but you could think of that as kind of resetting your program. And also, you're always expected to enter 2 values. So when your program runs, first of all, it's going to ask you which mode of the program you want to run. You want to run the calculator, or you want to run the quiz. And then from there, if you decide to do calculator, then it's going to ask you for which operation you want to do. And so you could do an addition, a subtraction, a multiplication, and so on. And it's going to ask you for the left and right operands, sorry. And so if you're trying to do addition, you know, it'll enter 2, 5, then it's going to do 2 plus 5, and so on. So most of these are straightforward. The only ones maybe I want to talk about is power. And for power, I did go over the POW function in CMath library that you can use because you don't quite know how to do loops yet. If you know how to do loops, you could technically do that with a loop. But if not, you can just call the POW function. The comparison, for that, you're going to use what we learned last class with the less than or greater than or equal to, those things. And so in this case, you're only going to compare whether the first number is greater than or if it's less than or equal to the second number. So you want to find out which number is bigger. So that's going to be kind of a complicated section there to do that. Modulus, we already talked about modulus. The only one that I usually get questions on is the inverse operation. So if the user does not enter any of these specific letters, like uppercase A, uppercase S, uppercase M, if they don't enter any of these specific ones, then you're going to just default. So that's going to be kind of like if you think about your if, else, if, else, if, else. So it's going to be that else at the bottom is going to default to doing what I call the inverse operation. Now, all that is doing is it's making the number the opposite. So it's kind of like the opposite of doing absolute value, sort of. So what that means is if you have a positive number, so if you have 2, it becomes -2. If you have 5, it becomes -5. Now, if on the other hand you have a negative number, so you have like -4, then it's just going to become a positive number. So the basic math way of doing that is just multiply times -1, and that's going to change the sign and keep the same value. So that's pretty much it. That's all you gotta do for that sort of inverse. And you only do that to the first number that you enter, so the left-hand operand. The other one just kind of gets ignored. So there is some error checking you have to do, the division by zeros, which is included in the power stuff, because when you do power, this is a thing that was earlier on Discord, when you do a number to the negative power of something, you can rewrite that as 1 divided by the number to the positive power of that. So let me draw you an example here. This is a very basic math thing you probably learned and forgot. If you have x to the negative y, this can be rewritten as 1 over x to the positive y. Okay, so if x happens to be 0, if you do 0 to any negative value, that will become 1 over 0 to the positive value of that. Well, 0 to any power is going to end up potentially being a 0, right? 0 times 1, 0 times 0, or sorry, well, 0 times 0 times 0 times 0. No matter how many times you do times 0, you are going to end up with 0. And so you're dividing by 0 in this situation, and so therefore you would have an error. So that's why it's a division by 0. Do we just print out the negative number, or do we have some statement beforehand? Oh, so when you go ahead and you pick the, so here, whenever you have a question about that kind of stuff, you can look at my examples. So somewhere here, I think I go ahead and show that one. Let's see, we have an example where that happens. P, that's power. D for division, M for modulus. Well, I get, by the way, in the beginning, you have to press A for calculator or Q for quiz. If you press something else, then it says invalid entry, goodbye, and the program ends. But do I not have any of them? I don't have an example where that happens, but you can kind of go with the example that I have up here that I just saw, which is the O one. I say the answer to life is, and then 1. So all you do is you write the answer to life is, and then you put the negative number instead. So in this case, if I've entered 5.99, then I've entered 2.1, and then I've selected T, for example, which is not an option here, then this would say the answer to life is negative 5.99. So hopefully that answers your question. Okay, so anyways, the division by 0 warning, you can see it somewhere here. I do remember, I think I have one. Yeah, right here. Division by 0 detected, aborting. So that's the kind of stuff you want to put for that. And that pretty much wraps up the first half of the assignment. The second half is going to be the quiz. So one of the Discord users went ahead and helped me out to make this assignment, or at least this quiz section. And so in this quiz section, you're going to ask a series of questions to the user, and depending on their answer, whether it's positive or negative, so whether they press uppercase Y or lowercase n, or sorry, uppercase n or uppercase Y, so yes or no, basically, you're going to keep a tally of a running score. Positive answers increase the number, +5. Negative answers decrease the number, -5. And so at the end of the quiz, you're going to have some value there. And if that number is positive, then you're going to respond in one way. If that value is negative, you're going to respond in another way. I believe in the case of 0, I do list here, I think that is considered like a negative score. And then if they get the highest possible score, which means everything was positive, then they get a special answer in that case. And that's pretty much how the assignment works. They ask, for example, can you tell when people are speaking Japanese? And then if they answer Y, when I say here +5, it means add 5 to the running score. If they answer no, subtract 5 to the running score. And that's pretty much how it goes, with the exception of one of them, which is the one where it's asking if you use or watch Bleach. And in that case, you don't expect a Y or an N. Instead, you expect an uppercase U or a uppercase W. That stands for U for use and W for watch. In that case, if they do put the uppercase U, then you subtract 5 to the score. And if they put the W, then you add 5 to the score. That's the only one that is different. There are some questions like this one, which is just a meme in the middle of this, that doesn't change your score. So whether they answer Y or N, you keep the same score. In addition to that, one thing I would like to point out is that what was that? What I wanted to point out from this? There's another 0-point question here. Oh yeah, if they don't enter a Y or an N uppercase, I mean, you can have the flexibility of accepting lowercase. That's not part of the assignment, but you can throw it in if you'd like. But if they enter another letter, like let's say they just enter an X, just randomly, that is going to be considered, I believe you don't change their score. Yeah, if the user gives anything other than a Y or N as a response to a question, the score to that question is a 0. So the score doesn't change. So we like to think of that as like skipping the question, okay? The exception, of course, being the U and the W one. That one is okay to take a U and a W. But if they answer Y for that one, then you don't change the score, right? So that's the one exception. And so yeah, that's pretty much it. If you would like to see an example of that, here for example, you press Q, so you run the quiz. It prompts you. I highlighted in bold the answers that I was typing into the quiz. It's not going to look in bold when you run it, but you'll see the letters. And as you can see at the end of this, after the last question, I go ahead and put W for watch. And then it gives me this congratulations message. So this is a positive message, which means I had a positive score, but it wasn't the top score. The top score is the one that says you are hereby granted club president. So yeah, basically you're applying for this Weave Club and so on. And somebody on Discord did it. So I guess if you guys are a little bit confused about the questions and why he put them like that, ask him, not me, because I don't know. I had to Google what Bleach was. So okay, all right. That's the assignment. Any questions on the assignment? Like I said, that assignment is due, I think, tomorrow night before midnight. So get going on that, I suppose. You have all the material to do that. Although, like I said, I'm going to continue talking about if statements today just to reinforce that, because it's an important concept that I want to make sure everybody gets. So, yeah, drink some water. Okay. Oh, it says we got 18 viewers. So, if you recall, an if statement is composed of the keyword if, which is a reserved word, and then you got a parentheses. It doesn't really matter if you have a space there or not. I don't usually put it, and I don't usually see people put it there, so I wouldn't put it there. Then you have something here, so you can say like if A is greater than B, assuming A and B are variables. And then again, you close it. Again, I don't usually see any space here, although I think it's courtesy to put a space between the variables like that and the operator. However, you don't have to. Again, it's just, I was saying at the end of last class, you want to make your code look nice, right? Consider it like your piece of art that you want to express yourself, and you do that through your code. So anyway, then you go ahead and you put the curly bracket, and then inside of here, you're going to put the action that you're going to do in this case. So I'm going to say cout A is less than B, which is true. This will only get executed if A is less than B. Otherwise, there's two scenarios here. A could be equal to B, or it could be greater than. So I'm going to say A is greater than B. And in that case, I'm going to say cout A is greater than B. And finally, I have the third possible scenario, and don't forget my little curly brackets to close that, is that the third scenario is going to be the else. So this is going to happen sort of no matter what. If I don't go in here and I don't go in here, that's kind of like my backup. I don't have to have that, you know, I can just not do anything. But in this case, it makes sense to have one because the scenario here is if the number is not bigger and it's not smaller, then it must be by logic equal. Okay. So, yeah. That's basically what we were talking about last time. Now, within that, I said that another way that you could completely do this, and in fact I show you the other scenario first, is you could do this using a nested if statement. So let's go ahead and rewrite this into a nested if statement, which I think is an inferior way of doing this, actually, but it's perfectly valid as well. In that scenario, you don't use the else if clause, you simply use the if else. So with an if else, we know that the else clause is going to get executed if the if expression evaluates to false. So in that case, what we need to do is we need to put a little if statement inside of the else clause with its own local else statement. As you can see, I'm not really changing a lot to be able to accomplish this. I'm just moving things around and moving around curly brackets. And then I gotta put one here, and that's it. So this will do the exact same thing as the code above. But the difference is, here it's just technically one if statement that has an if else clause. Whereas here, I have an if else clause, and within the else clause here, so within this, I actually have another if statement that is inside of that. And of course, this is known as a nested if statement. And again, both of these codes will do the exact same thing. If you don't believe me, you can go ahead on your own time and actually type it in. But it's very important that you understand that they do the same thing. And to further understand that, let's look a little bit closer at the curly brackets and how they work, okay? So this is going to be that discussion about scoping. So you can see the curly bracket is used to denote the beginning of the part of the if statement that actually gets executed when it evaluates to true. So if I have something like this, if A, like that, in this situation, A is some sort of variable. And if it's a Boolean variable, if it's set to true, then I'm going to go ahead and execute this. If it's set to false, then I'm going to execute that. Actually, technically, if I don't have an else clause, I'm always going to execute this. So it's more of like, if A is true, I'm going to do the green line. And if A is false, I'm going to do the red line. But however, if A is true, I'm going to do the green line and the red line technically. So I'm actually doing both. So this is if true. That looks ugly. So I have an idea how to color code this and make it look pretty. Hold on. So A true, we're going to use green. That means this gets executed and this gets executed. And maybe this gets executed beforehand, okay? And now we're going to use a different color, like not red because we have red in there, but maybe purple. We're going to do this if it's false. So if A is false. So the purple lines get executed if A is false, that meaning that this always happens and this always happens. But what changes is whether or not this line runs. Now, if we have an if else, then it's a completely different thing. In that case, this runs, and then these are combined. In fact, I can probably overlap the colors like that. So the green stuff runs if it's true. You can see this runs, and this runs. Whereas when it's purple, this runs. Oh, why didn't it change to purple? This runs, and then this runs, and then this runs, okay? So that's, again, your if-else. So, okay. I'm just trying to repeat that as many times to make sure we're all on the same page here. But here's the thing. So looking at the curly brackets indicate where this starts to get executed, right? So even though it's good practice to space it and write your actual code at the next line, so I could do my like C out here or whatever, as I did here, you know, I'm doing the C out down here. This is good practice. But in theory, I could write code here and it would compile and be okay, right? Also, if it's a single statement that I'm executing, I actually don't even need the curly brackets at all. So I can do something like this. That's going to be okay. And then the next line, if I have C out, hello, I guess. If A is true, I'm going to say hi, and then I'm going to see hello. If A is false, all I'm going to see is hello. I don't need the curly bracket, and it doesn't actually, I do the spacing because it's easier for my eyes to see, but C++ ignores it. So I could just as well have spaces here, which would be extremely confusing for somebody to see because they would assume that it's inside of the if statement, actually. This is, again, I think I made a spiel about this last class as well. So anyways, the reason we put the curly brackets is because if we want to run more than one statement inside, the curly brackets denote the beginning and the end, okay? Furthermore, when you do the else clause, you also have the little curly brackets as well. And when you have a nested statement, it has its own set of curly brackets inside. Now, the curly brackets don't just indicate what lines you execute, but they also create what is known as scope. So the curly brackets create a block of code, and that block of code has its own scope. Now, what does that mean? Okay, so if I have a variable A, and maybe that variable A has the value of 5 in it, okay? I cannot redeclare another variable A. Like I cannot. If I try to do this, if I try to do int A and then do like 5 or 6 or whatever, this will not compile. It will give me an error because I'm within the same scope, okay? So that's important because I'm going to come back to that in a second. Now here's the thing. I have a variable A, okay? And even if I'm not using the if statement, I can still go ahead and randomly throw in curly brackets in my code, okay? If I do that, of course, if it's part of an if statement, then you do the decision whether you go in here or not. But for now, get rid of the if statement, just the curly brackets themselves. If I do this, and in here I say cout A, I am going to be printing this A to the screen. So I am going to be printing 5, okay? Furthermore, if I say A gets 8 here, and then later on I say cout A, this is going to print out also 8, okay? And if I did it in here, this would print out 8. So I'll put it as a comment next to them what they're supposed to print, okay? So that's what's going to end up happening. Here's the thing though. If I declare a variable inside of this scope, so if I go in here and maybe let me move this up a little bit so I have space. If in here I decide to declare a variable called B, I'm putting maybe 7 in that, okay? This variable is being declared in this scope, and this scope is only running from the beginning to the ending of the curly bracket, so only what's inside of the purple square. That is the scope of the variable B. If I in here modify B, print out B by saying cout B, I'm gonna get 7. But here's the thing. If I try out here to cout B, it's not going to work. It's going to give me an error because variables can only reside in their scope, in their local scope. This is known as the local scope. They cannot be accessed outside of that. When the scope finishes, any variables that was created in that scope get thrown away and they're gone forever. They get discarded. The memory that was used to create those variables is given back to the operating system to hand it out to other programs. That way it doesn't hog them. And that's it. You've lost it. A will be 8 outside of the scope. Yes, it will be 8. Because here's the thing. For variables created inside, it doesn't matter. But what you can do is you can access variables that are not in your local scope as long as they're sort of in a scope outside of yours. So you can think of this as like layers. You can only go into your outer layers, but you can't go into your inner layers. So like if you think of this like a mountain, you know, here we have what is actually known as the global scope. You can think of that as like the land, okay? And from there, we have a couple of mountains, okay? And from there, you have maybe a mountain inside of a mountain, okay? So this is, for example, the global scope. And then here is its own set of curly brackets, okay? So we got a curly bracket there. So if I declare variables here, they only exist there. But I can also look down the mountain at any variables that I've declared here. And obviously before, you can't look into the future, okay? So you can look at those variables and you can even modify them. What you can do is if you're here or here, you can't look up and modify variables there. You can only work with variables inside of the local scope or down, but you can't go up into them, okay? So if you got yourself a bunch of curly brackets like this, and you got some code right here, some variable that was declared right there, that variable is accessible here, here, in fact, everywhere, technically all the way from here to here, even inside of the other curly brackets, okay? However, if I go ahead and declare a variable here, it's only accessible here, inside of this one, and right here between these two, but that's it. It's not accessible out here, or here either. It's not accessible there either. Because that's not accessible. In fact, I'm going to get rid of the colors where it's not accessible. So it's only accessible where you see the red. Finally, if I declare a variable here, then it's only available in there. It's not available down here, or down here. Okay? Does that answer what you said when you said A will be outside of the scope? So, yeah. Okay? So, going back to the actual example with numbers here, you can modify variables that have already been created if they're not within your scope, as long as they're sort of in an outer layer. But you can't go inwards. Okay? So while I can modify A here, anywhere in here, and then it will permanently modify it, I cannot change B from outside of it. In fact, it doesn't exist. It doesn't even see it. It gets even more complicated. You can while you cannot, so remember what I said like maybe 5 minutes ago. You cannot have two variables with the same name. It will give you an error as long as it's the same scope. But if you're inside of a scope that is not where the variable was declared, you can have variables with the same name. So you can do this. You can do int A gets 5. Okay? And then you go ahead and you create a curly bracket. And in here you can say A gets 7, and it's going to modify the A that you declare, right? But here's the thing. You can also say in A gets 10 here. And this A is perfectly legal to declare because it's inside of its scope. And now this line here is actually modifying this A. It's not modifying the outer one anymore. Because what the operating system does, and the compiler when it's creating the code is going to do is it sees an A equals 7. So it gets to the, first of all, when it sees this line, it allocates memory for that A, it allocates memory for that A, and then finally it gets to this line to actually run that piece of code. It says, assign the value of 7 to A. What it's going to do is it's going to start at the top of the mountain and check if there's any A's here. And if there's no A's there, then it's going to go down the mountain. Again, it cannot go up the mountain, only down. Okay, it's a very steep mountain. So then it's going to check here. If there's any A's, then it's going to modify those A's. If there's no A's there, then it's going to check the bottom layer. And if there's no A's there, well, suppose there's an A there, then they will modify that one. If there's none, then it'll stop looking and give you an error and say that variable was never declared. Okay? Furthermore, if there's A's on each level, it's the moment it finds the first A, that's the one that is going to modify, and then it's going to stop. So it's not like it's going to try to change all of them. Only the first one that it finds. So this right here is only going to be modifying that local A and not the other one. Okay? Now you are asking yourself, why would you do that? Okay, there's a lot of scenarios where this is a horrible thing to do. You don't want to have the same variable names within different scopes because, you know, here, yeah, these two lines are very close to each other. But now imagine that there's about 10,000 lines here in between that declaration and the usage of that. It's going to be, and then maybe there's also like 5,000 lines of code here, okay? So you got a bunch of code here, a bunch of code here. Somewhere in that massive wave of code, there's the int a declaration, and then you have your assignment. And then you see this, and if you don't actually have like eagle eyes to see that line of code, you may assume that that is going to modify that code. In fact, if you're writing code and you don't see that somebody else declared an A here, you may write something like A equals 8, and you might assume that it's modifying the outer one because you never saw that somebody declare one inside. And so then you run it and then it's not changing it and you're like, what is happening? And then you go and look in the code and you see that somebody declared A inside as well. And you're like, oh. And it's really bad because at that point, you're kind of screwed. You can't really access the outer A. Like you're just stuck. You're kind of stuck. Because the program is not going to be smart enough to like skip that A and keep looking. And so it's not recommended to name your variables the same unless there's a very, very like obvious reason for doing that. The only obvious reason that I know is when you're creating your loops, which we'll talk about maybe tomorrow or the day after. And there's something known as a for loop. And a very popular variable for a for loop is the I, J, and K, which are little counters. And you do have a bunch of them, and you reuse them usually. So that's the only scenario where I personally have seen the reusability of variables being accepted. Otherwise, people will look at you and be like, you're crazy, don't do that. And if you're working somewhere and they see that, they're like, don't do that or you'll get fired, kind of thing. So, you know, you want to make your variables significant in terms of their names, and you want to avoid making code harder to read than it is. I mean, it's already hard enough to read code for you to try to make that intentionally obfuscated or confusing. So, yeah. So that's basically how scoping works. Let's go ahead and try out a couple of examples on the computer so you can kind of see that in action, you know, in the flesh. All right. So let's just do the example with the A and the outer scope so you can see that happening. So here we have 55, and then we've got, move the keyboard a little bit here. Let's say curly bracket. And of course, you don't usually just throw curly brackets around. This applies more for like when you're using an if statement or something. And by the way, here's something cool that I was gonna say, but I just forgot and then I remembered again. The curly brackets in main, those also indicate scope. So actually, what we call the global scope is technically here. And you can actually declare a variable A here and assign something to it outside of the main function. So far I was like, you know, this is where you code. This is your life right there. And those space between the main and the return 0, that's where you've been coding so far. And that's where you should still code at this point. However, it is possible to code out there as well. And that is known as the global scope. That's the bottom of the mountain, okay? Now, while you can declare variables there, those will be actually called, so this will be an example. This is an example of a global variable. These are very looked down negatively by the coding people per se. Like, you know, I don't know how to work that, but it's like it's looked upon as like, what would be a good metaphor for that? It's like, imagine you're going to a really fine dinner and there's a lot of people that are very like educated and, you know, like Titanic style, they got all the different forks and stuff. And, you know, suppose that you're grabbing the salad fork to eat a steak and people see that and they look at you and they're like, yeah, he has no idea what he's doing, you know, and they kind of judge you in a negative fashion, you know, for the right or the wrong, they judge you, right? And so that's like the same idea of using a global variable. People will look at you and judge you. You are either some master genius and you're doing something insane, or 99.9% of the chance, you have no idea what you're doing. You don't belong here per se, okay? So they're gonna be like that. The book did that. What did the book do with the global variables? I don't know. But yeah. So the reason why is this. Think back at the mountain example. A global variable is accessible anywhere in your program at any time, right? So if I go ahead and say int a equals 2, and there's 100 different people working on a programming like a project at work. So I try. But yeah, if you're working in a project with 100 people and you declare a variable with the global scope, you have now sort of made that variable accessible to other people. And even though they may not necessarily be using it, they can't ever really deal with, like, it's just going to be there. Like, they may not want access to it. It's just going to be there. It's always going to show up in their code, basically. And furthermore, it may conflict with other things, because here's the thing. We haven't talked about functions, but if I wanted to call a function A, if I wanted to say, and again, we haven't talked about it, and once I will, we can come back to this, but I can create a function called int A like this. Just like main is a function, you can do that. Well, I can't anymore because I have a variable A, and that's going to conflict with that. So I've sort of removed that possibility from being done in the program, amongst other things. And also, people try to do global variables to get around things like communicating information between functions, or when you learn about recursion as a way of communicating between different recursive calls. And frankly, it's sort of like a cop-out to much more appropriate ways of coding. And that's why people will look down upon you and be like, it's a new thing to do, right? New friendly. So yeah, no global variables, to the point that I think in the syllabus or in the rubric, there's a very clear section saying you're not allowed to have global variables in the class. I think it says that. That would be the 202 one. I can't remember. But yeah, it's that hardcore that you'll actually lose points if you have global variables. Okay. However, I need to teach you what they are, because if one is to understand the great mystery, one must embrace a broader view of programming. So yeah. Okay. So anyways, we're gonna leave it in there because we're gonna see how it does things. But yeah. Okay. So now we have in the global scope, we have something now, and now in the function scope here, we have an int a, and then inside of this little local scope, we're gonna have another int a. Like that, okay? So now we got a bunch of int a's, and now we're gonna mess with them. First of all, let's just go ahead and create a cout. So it's like inception. So this is the deepest layer A, like that, okay? And then let's just run with that. Just make sure that the code actually compiles as it is now, okay? Deepest layer A is 22. Good. Because that's what you have here, right? So let's go ahead and put out here main function scope, and print out an A there. And finally, yeah, we can't even, to access the global one, we have to do that before we declare it. So cout global scope A. Because here's the thing. Once I declare that A equals 65, I lose access to the global scope one, pretty much. There might be a way to get it that I can't remember off the top of my head, just because it's like trying to remember how to do something you're not supposed to. So it's like, why would I remember it, kind of thing, right? So yeah, but I think there's a way. Probably with scoping. Google time. Access variable JavaScript. No. Scope resolution operator. Good. Yeah, but what would be the appropriate thing for that? Oh, I guess you just don't put anything. Okay. I kind of thought that was the case. So here, I think to access that global scope after we've declared it, we can do : so global ? A. With those semicolons, with those colons like that. There you go. Yeah, cool. All right, let me just add a space there because that bothers me. There's no space there. Let me space them out nicely. I put the space in front of the thing. Okay, so now again, you want your code to look good, right? You also want your output to look good. Okay, so let's look at this, all right? And maybe I'll move this to the side a little so you can see it next to the code. Yeah, this works. Okay, so as you can see, after the program starts running from main, right? So the first thing that's going to happen is this line of code right here, and then we say global scope A, and you can see that A is equal to 2 because it's accessing the global scope. From there, we are declaring a local variable to the function that is called A as well, and it has the value of 55. From there, you can see that if you go all the way, if you skip down here where it says main function scope A, it has that 55 in it, okay? But before we do anything inside of this little scope, which is the deepest layer, we declare yet another A, where it has a 22 in it. And then we can even print it out by just having A. So you can see that every single one of these, all I'm scouting is A. With the exception of this one where I'm doing a little bit of a hack. Oh, you can't see where I'm pointing. There we go. So you can see that all of these, I'm printing out A. Like that's all I'm doing is printing out the A's. There's no difference exception for this one where you're seeing the little hack there with the colons. But for the other ones, it's just A. And yet they're printing different values, which is a little bit scary. Because like, if I try to modify them, so let's go ahead and modify A here. Let's go ahead and say A gets 333, or I don't know, whatever I typed. That's not going to change anything in your output because I've already printed it here. In fact, I mean, if you want to see it, I can print deepest layer again, like that. And then you should see it print with the different values. So first with the 22 and then the 2233. But then when you go see the next A right here, it's still printing the 55 from the main function. And finally, if you want to access the global scope, the hack per se is you have to use the scope resolution operator, which we'll very briefly mention, but it's more of a 202 thing. But as you can see, there's a little hack to access global variables. You don't normally with the scope resolution operator, you put something to the right of the colon, like you put the class name if you knew what a class is, or a struct and that kind of thing. You would put that here, so like potato or something. But in this case, you just don't put anything, and as you can see, like, ooh, it prints out. Yet again, the power of Google. I want to preach the power of Google because it's very important you guys understand that. I at some point I might have known that. I did not remember it. What did I Google? Let me see what I actually Googled. I Googled here. The way I found that within seconds, did this live. Oh, snap. I modified the audio a little bit. I think we're okay. Yeah, it should be fine. We'll see. But yeah, let's see, let's back up a little bit. I Googled access global scope variable C++. And from there, it was literally the first answer. It had it there, but I clicked it anyways to see it. And from there, I saw the line of code. I can't scroll down. It's right there. There we go. I saw that line of code, which confirmed. So as you can see, the power of Google is very important that you guys use it for good, not for evil. Don't Google how to make a bomb, okay? So yeah, unless you're farming and you need to actually use a bomb, I guess that would be. But still, I would not Google how to make a bomb because you might blow yourself up in the process. So you can probably buy a bomb if you're using it for legal purposes. It was a constant that I declare outside. Is that okay? I don't know. The TA is here. So you may be able to make your case to the TA who's the one that's grading it. So, yeah. But I don't know. Like I said, he takes care of the grading. So if he wants to make an exception or whatever, it's his choice. I don't get involved with that unless it's I play arbitrator if there's a dispute. So, yeah. Okay. So, all right. What else do I want to do with this? Well, just to show you, I guess, as a proof, if you're not convinced, like here, I can't just go ahead and declare A again there. Like, I can't do that. Because in this scope, I already have an A. And this will actually give me an error saying redeclaration of int A, right? Because this A, I have an A in the scope already. So I can only declare variables with the same name if it's a scope, in that local scope, I haven't declared a variable already, okay? So that's why I can do this A, I can do this A, and I can do this A, even though I have this A, but I cannot do this one because I've already done it, okay? So that's kind of an important thing. Also, yeah, let me do the example where I declare a variable inside of the scope here. So if I do like int b gets 22, or I keep using the same numbers, like it's hard. It's just the ones that come to, I guess my brain is, the RNG of my brain is those numbers, which works the first time, but not after the 40th time. Oh, that was something. Okay, so what was that noise? Okay, so if I do that, B is going to get 6, 6 there. But if I try to see out B here, well, it's not even a compile. So here, let me first show you that it actually gets you 6, 6. B 6, 6, okay? So if I try to do see out B here, it's not even going to let me compile because it says B was not declared in this scope. Now, there's that magic word. You can't see it here. Let me screw it over. There's that magic word, scope. So now you know what that means. Now you know when the errors of scope come up, then it has something to do with where your variable was declared and is not being accessible within that scope. So, yes, you can understand errors better now. Is there a definition in the book of scope? I think there is. I'll leave it to you guys to go in the book and look up that definition because I don't know, honestly. Let's see if I have one here somewhere. Scope. Nope, I don't have one. So you guys can go and write if there is a formal definition of scope, you guys can check it out. But I think more importantly, and if I was to ask you in a test what a scope is, it would be more of a question of like, I'd ask you a question with the curly brackets. In fact, I pretty much recall that I did that last time that I taught 135. I had a question where I had like curly brackets, like I had something like this. I had curly brackets all over the place like this. And then like one here or something, okay? And I numbered these lines. I numbered it like 1, 2, 3, 4, 5, 6, and I guess 0. I would have numbered that one, but I don't want to renumber, okay? And I said, for example, line 1 is accessible from which lines? So like, where is line 1 accessible for? And the answer is lines 2, 3, 4, and 5, but not 0 or 6. On the other hand, if I said line 2, where is that accessible from? Well, that's accessible from lines 3 and 4, and actually also 5. Yeah, also. Oh no, not 5 because I see the curly bracket there. Yeah, so it's only accessible from 3, and that's it actually. Yeah, actually just 3, because it's kind of harder to see because I'm trying to, because I want to do this like naturally to make my life easier, you know. This makes much more sense for me. Like if I space things out like this, it helps my brain to actually see what is within each scope. But in the test, I just put them all flat, because otherwise I kind of give it away. But yeah, okay, so there we go. So now it actually makes more sense. So line 2 is only accessible to line 3. Line 4 is only accessible to lines 5. I guess to yourself. All of them are accessible to yourself. Like 4 is accessible to 4, right? Line 1 is accessible by 2, 3, 4, 5. Yeah. Line 0 is accessible by everything. Lines 3 is only accessible by 3 itself, I guess. Line 5 is only accessible by 5 itself, and so on. Here explain all the use of scope resolution operator with example. Yeah, Geeks for Geeks is great. I probably have that link in my 202 class for it. They have the example with the global scope. So yeah, check that out if you'd like. Ooh, static variables. Do I need to talk about? No, I don't need to talk about. That's a 202 thing. Cool. But yeah, if you guys are taking 202, then when you learn about classes, you definitely will practice the scope resolution operator. So yeah. But anyways, I think this is the kind of question that you will see, so that I know that you understand how scoping works in terms of variables, rather than me asking you like I might ask you like, explain how scoping works within like the global scope versus local scope and that kind of thing. But I'm not going to ask you like, please define global scope or please define scope. That's pointless. Anybody can regurgitate information from a book. I want to know that you understand how to do this and you can code. That's what I want to make sure you get out of this class, is you can actually code. And yes, it's good to know some of the jargon so you can better express yourself with others. But again, there's a limited usage of that. So yeah, that's the kind of thing that you can expect to have in your midterm or your final, because final is comprehensive. So yes, I make the test, but the TA will grade it. So yes, I'll we'll talk more about it when we get closer. So that pretty much covers scope. As we do it more, you'll practice. However, just to make sure you really get this, this is the same situation with scope. It's just that now I've made it into an if statement, but it's still using scope rules because it's got the curly bracket. So whenever you see the curly bracket, think scope. In this case, by the way, if 1 is always going to run because any number that is not 0 evaluates to true. So that's actually a way of me just coding an if statement to just run forever. So that actually will do the exact same thing as before. Like you should see the same. Well, I gotta get rid of the B here. That will run like that. So yeah, okay. Let's see. What else do I want to say? Anybody have any questions? I guess. We talked about short circuit evaluation last time. Here's a proper definition of that in case you're curious. Short circuit evaluation, the process in which the computer evaluates the logical expression from left to right and stops as soon as the value of the expression is known, which is basically what we said last time, which is, if you have something like A and B and C, if A is false, then it doesn't need to check the rest because it knows that this expression will be false. It's impossible for it to be true at this point. So it's like, why check the rest if I can just keep going and speed things up? And the computer wants to do things quickly, so it will cut any corners that it can safely. So, yes. There's that. Again, with logical expressions, we know that's the not, but you can also use the word not apparently. No, actually not. Not in C++. In Python you can. You can, however, for the and, you can use the ampersands or the keyword and like that. For the or, the 2 vertical lines or like that. That works as well. Nested if statements. Technically, the official term of having something like this. Here, let me move this over here. What is happening? Hold on a second. Why is it still showing? There we go. I have 4 monitors. It's kind of hard to organize things. So, yeah. So technically, while these curly brackets indicate a scope starting, we actually call the entire content of a curly bracket a block. Okay? So a block. And a block has its own scope. So, yeah. It's a sequence of statements to be performed. Yeah, okay. So that covers chapter 7 then. We're done with chapter 7. So now we can move on to chapter 8. And there were no more questions, so good. All right. So actually, technically, even though it's not chapter 8, it's chapter 3. Yeah, it's the second part of chapter 3, my bad. So even though we already covered chapter 3, we didn't cover the second part of chapter 3, so we're going to do that now. What do we do if the if statement keeps selecting one option regardless of input? If the if statement keeps selecting one option regardless of input, the if statement will choose whether it evaluates to true. So if your if statement is always executing, it means that the logical expression is always evaluating to true. So if that is not the case, then what's wrong is potentially your logical expression. So you need to actually look into the logic that you wrote inside of the if statement in the parentheses and figure out why that is happening. So that is going to be where you need to look for your potential error. So yes. Okay. So let's save this. Still compiles. At some point I might post these online. That's why I want to make sure they're good. Let me close that. Okay. So now we're going to talk about formatting output. Again, this is chapter 3, second part, I guess. And so first, let's talk about some special characters, okay? So if I go, C out, and I use like a string like hello world, and I use end line here, I'm just using your good old typical old school characters, right? But here's one thing that you might run into, okay? Suppose that you actually want it in the what is printing out here. So like, hold on, I guess I gotta change the program. That will help. There we go. Okay, so there's that. So what if I wanted to actually put curly brackets inside my output? Like I wanted to say a quote like, he said, comma, let there be light. Okay? So I actually want to print out quotes. Like I want to print out quotes in my output. But the thing is, the quotes are used to indicate the beginning and the end of a string. So then I'm like, can I use them? So can I do that? Can I put quotes inside of quotes? And if I run this, it's going to give me errors. It's expected semicolon for let, because it's thinking that's where the string ends and so on. So what can I do? Well, I suppose one solution could be you can use 2 single quotes like this. And I think you get away with that. Like that. But those don't really look like double quotes. They just look like 2 single quotes. It looks kind of dumb. So how can I actually like print out the double quotes? Well, what you need to do for that is use an escape sequence character. Okay. So by using an escape sequence character, you can print out common characters that are used to indicate things like beginning and end of a string. And by the way, this actually applies not just to programming, but in Discord is the same thing. In Discord, if you've been using Discord, you use the little backwards apostrophe 3 times, and then you press C, and then you write some code here. So like C out blah blah blah, and then you put 3 of these again. And if you do this in Discord, it actually prints it out in like really cool color coding. So you get to actually see like cool colors and stuff. Can I do that? I don't know if this is gonna work. The problem is you can't see the bottom of it. How can I do that? Nope, there's no way. Sorry. I can't figure out an easy way of doing that. Hold on. Maybe this one will work. And then if I just... There we go. Okay, so now you can do that. All right. So like if I do 3 of those, C, and then I can actually just copy and paste my code from here like that. You can see that it color codes code pretty cool, right? By using those 3 backslashes and then putting a C there to tell Discord that this is a C program. Okay, but then what if on Discord you just want to print out the 3 slashes like this? It doesn't let me. Like, and if I put 3 more, it shows nothing, right? So like I have no way. I can print out 1, I can print out 2, but I can't print out 3 because it just assumes that you're trying to write code. So I can't do it. So actually the same thing on C++ will work for Discord. And the escape sequence is going to be a backslash. So if I put a backslash there, and a backslash there, and then the backslash before the other one, now I can actually print out the 3 things like that. But notice that it doesn't print out the backslash. It just prints out the what you're trying to escape from. So this works on Discord too. So it's not just a C++ thing. Escape sequences are popular for many things that actually involve special characters. And this is actually how when I was trying to explain to people how to do this, You know, I was like, well, this is what you do. Then you write code, and then you put 3 of these again. I had to do it like this so that they could see that. And then when they manually did it, of course, they'd actually get the boxes. So, yep, that's pretty much that. So that's the concept of an escape sequence. And in C++, it turns out that it's actually the same thing as Discord. It's the backslash. So if I want to put a quote, I can just do backslash and then put my little quotes, and then do the other one over here, and I'm good to go. I gotta get rid of the other ones. There we go. There you go. Now we get like proper quotes, not like the weird discount quotes. Yeah. So there you go. That is called escape sequence, and it's useful for printing that. It's also technically useful for printing out characters, individual characters. Like, even though in a string, I can, as I show you with the quote unquote the discount quotes like that, if I was trying to print out a single character, I use this, right? I use the single quotes. Now, what if I just wanted to print out a single quote in that scenario? Well, solution would be you could just do it as a string, like that. And then put an end line so you can see it better. And you can see the single quote like that. But if I really wanted to commit to using a character, like suppose I want to save in a car, so like I have a variable, a car variable C, you know, and I want to save the single quote. Can I do this? Actually, that's a good question. I don't think I can. I shouldn't be able to, but I don't want to lie to you guys, so maybe it'll let me do it. Yeah, it doesn't let me to do it because it thinks it's a string. So what if I want to actually assign a car to have a single quote? Well, I can't do this because it gets confused again. I think it will. Yeah, it gets confused about that. So again, I need to have an escape sequence for that. I need a backslash, and then I should be good to go, as you can see. So it's also useful with cars if you want to put it a single quote, because you use a single quote for cars. Also, this gets like inception tier. What if I want to print out a backslash in my output? Like here. Can I do that? Look what's going to happen there. Actually, in this case it will, but it is some really nasty things. It actually, instead of printing out, he said, let there be light, it says, ebe light et da. It's like, what? What just happened? That's because the backslash R is a special, it's a special escape sequence that is, I think, carriage return. So it goes back to the beginning of the line, and then it overwrites things, I think. Okay, what about there? Like backslash E, is that gonna be okay? In this case, it just printed out some weird, nasty thing that is definitely not a backslash, right? So here's the thing. The backslash, our escape sequence character, needs an escape sequence of its own. So what is that gonna be? Well, just 2 backslashes. And so there, if we do that, you can see it prints out just 1. And I can put it in front of the R, like I had it before, and that won't also be a problem. So yeah, this is escape sequence inception. You need normally a backslash to escape from other things, but to escape a backslash itself, you need yet another backslash. And what if you want to print out 2 backslashes? Well, you can't just escape one and then do the other one. You're going to run up again into that weird issue again. Yeah, see that? So you're going to need 4 of them to print out 2 of them. Because each backslash needs to be escaped individually. So this is, we're going deeper into the inception here. Okay? So other one that you know or you have seen with the escape sequence is actually backslash n. The line feed is backslash n, remember that? I mean, I know I use n line a lot, but backslash n also works. As you can see there, it puts it on the next line. That's technically using escape sequence. And like I said, backslash r is a carriage return. And there's a couple of other ones that are out there, but you don't really use them, so we're not covering them. In fact, backslash r you rarely use. I actually didn't remember that the moment I did that there, so I was kind of lucky. Will an escape sequence of 4 backslashes be 8 backslashes? Yes, absolutely. So here, we have 4, so we're just going to copy paste because I don't feel like typing 4. You know, I don't know if that was really a save of time, but yeah. There you have it, 4. So you need 8 for 4. So you always need twice the amount, okay? So it doesn't go exponentially, I suppose. You multiply times 2. So those are all going to be your special characters that are, and these are, and the escape sequences. So escape sequence character in C++ is \, and also in Discord. So there you go. You practice programming when you're using Discord now, because you can use it in that. Also, another big thing, and by the way, I have a definition here for manipulator, but I don't know in what context I was using manipulator that said used to format as output. I'm going to cover myself and say that, oh, by the way, that one is not a \, but it's also useful for signifying comments, because technically that's a different thing. So just wanted to throw that in there. But I have a definition that says manipulator is used to format output. I'm not sure where that came from, but I'm just going to throw it in there just in case it comes back later. But okay, so more into formatting output. Let's get more serious on this. There's actually a library called iomanip. Ah, that's where that came from. Yeah, so I always call it iomanip, but what it really stands for is input output IO manipulation, or maybe manipulator. Yeah, that's where it comes from. Okay, so IO usually stands for, when you hear IO, it means input output, so like entering stuff or reading stuff. And then manip stands for manipulator, which means used to format output. There we go. So I'm glad I have those reminders, because otherwise I would forget to mention this kind of thing. But I guess that's where that name comes from. I always just call it iomanip. I don't know why, but I guess iomanip would be a better name for it. So apologies for that. I'm still gonna call it iomanip, so too bad. But anyways, okay. So this library, this is a header file that contains commonly used manipulators. Actually, yeah. That are used to format output. And so, while there are tons of libraries, and one of them that we will explore later on is ncurses, which is the one that's only for Linux, which is why you can't just code on Windows for this class. We haven't so far touched anything that's OS exclusive. So far what you've learned should work in all computers, regardless of the OS, as long as it has a G++ compiler. But ncurses won't. But anyways, iomanip, see, I say it like that, is it will work in all OSs. And so that has a couple of useful functions that allow you to manipulate and format output of text, such as remember when we were printing out a float and it gave us to like 5 decimal digits of accuracy? We can make it only print 2 or maybe print 10. We can make it not print any decimals at all. We can left justify, we can right justify, we can do a lot of things to make our output look prettier on the terminal. So that's what that header file is used for. And I don't know yet if there's any assignment that you make use of it, but you may still use it as a way to make output look prettier, I suppose. So let's go ahead and just kind of go through a couple of these so you get a feel for it. So just kind of start out with a clean slate. Let's see which one I want to do first. Let's do setW. So there's a function called setW, which I do believe it stands for set width. And it takes one parameter. So parameter, I'm talking about the variables inside of that. So if you think of the pow function, which is the power function that comes in CMath library, that's like 2.5. That means 2 to the 5th power. We say that it takes 2 parameters. The first parameter is the base, and the second parameter is the exponent, right? Another example is the absolute value function. That one just takes 1 parameter. It just takes a number that you're going to do the absolute value of. And both of these will return to you something, which is the answer to that mathematical operation, right? So in this case, setW is going to take 1 parameter. And that parameter is going to be the number of columns. Okay? So what setW actually does is it makes you print out output with a specific number of columns. And so I think it's just so much better if I just if I print it out. So yeah, let me just show you by example. I think that makes it so much easier to understand this. So let's say that I have the word result, or I don't know, gross net income. Let's say we're filing our taxes. Okay, so we got our net income. All right. And if I have our net income, maybe I have a variable called int A, and maybe we'll have a float B. Int A has $123, and float B has $22.44. Okay, so if I go ahead in my net income and I say A, that's a really bad income, but yeah, COVID-19 and everything, I don't know. And then we have gross income. I don't know. I gotta file my taxes actually, but I think I have until July to do it, so I should be okay. Let's see, where's the error? Oh, here we go. All right, so we got net income and we got gross income. Okay, I think that's good because right, gross income is after they get rid of you, after the tax man takes their cut. So here they took a big cut. So okay, so suppose that you want to space this out to the right. Okay, so you want it to be all aligned to the same column. All right, so first of all, we could manually space out things like this, you know. I can put a space there, need one more space, and now it looks lined up, right? And then if I want these two numbers to line up, I could put two spaces here, and now it's lined up. But then what if my income really goes up? Next time I run the program with different income, or at least different number of digits, it gets unaligned, right? So what if I wanted to be consistent? Regardless of how many numbers there are, I want to like justify it to the right, or I want it to always take the same number of little columns, you can think of little blocks as possible. Okay? So I can use set width for that. So what I do is in my cout, I can call set W, and let's go ahead and set it as 6. Okay, that should be enough. And let's just run it and see what happens. You can see that it, I think we went a little bit too far. Ah, I see what happens. Okay. I forgot to erase the spaces here. Yeah, in fact, let's just get rid of all spaces there. There we go. Okay. All right. So you can see now that we set it to 6 spaces, and by default, everything is right justified. So it pushed it to the right and it lined it up. And now if I go ahead and run this again, but I put a 0, so like another digit, you can see that it's still right justified, but now that all the text moved this way. Now, if I do go over the limit here, so like let's say I have all these numbers like that, then it's going to kind of overflow. It's going to try this hardest to kind of maintain things right justified. So like you can see it try to fill every single spot possible, but it doesn't want to cut off digits, so then it kind of goes overboard. So if I want to fix that, I can change the set W to something bigger, like 10. And so now I as long as I go under 10 digits, it'll still be okay. I can also add more values there. Now we're making some real bank here, because those are dollars, right? In fact, we could throw a little dollar sign in there. And there you go. So what set width is going to do is it's going to define how much of a space you want before everything is right justified. Now, what if I want to left justify? So by default, everything is right justified, okay? But what if I want to left it? And by the way, this is very different than when you think of writing like a paper in like Microsoft Word or something, right? Because that's always left justified. You write things, and in fact, this looks left justified as in general, right? Like this whole thing. But C++ by default does right justified. So if I want to switch it to left justified, what you do is you go ahead and you just call left at some point. And unlike set width, when you do left like that, I do believe it changes it permanently. Like it goes forever. It just changes it forever like that until you change it back. How do you change it back? You call right again. As you can see now, it just squished everything to the left. However, if I had another value after this, so whoa, and then here one that says like LOL, you will see that those are nicely evened out because it still has a block of 10 for the first set of numbers, but it just left justified that, so now the spaces are at the end, not at the beginning. So you can use this by setting the width of each number that you print. You can line things up so that they look really pretty. So you have like a column that is lined up, and then you have another column that is lined up, and so on. So that's the big advantage of using set width and right and left justification. If I want to switch it back, because here's the thing, if I go here and then I keep printing stuff, so like hi, well here in this case it shouldn't do anything. Hi again, but let's just show it. I don't know what that noise is, if you guys can hear it. But yeah, okay. You can see that nothing really is happening here. But if I went ahead and I set my width, can you guys hear that noise? I hope you guys can hear it. It's so weird and distracting. There's like drilling going on or something. So you can see here that it's still left justified. But what if I want to switch it to right justified? I can just call right again. And again, unlike set width, where like it's only affecting the next variable that you print after that. With left and right, once you change it, it says change forever until you change it back. So there you go. Now we got change back. And if I had more than one example of that, it would be easier to see. So like that. Let's make a bigger number, I suppose. And then maybe add a third set of text here. There we go. Easier to see that it's right justified. And if I go ahead and remove this, and by the way, one way you can remove code without removing it is wrap it in these kind of comments like that. Well, I guess in that case, I also got to wrap up one of these things. And now that comment is ignored. As you can see, it's in green. And there we go. Now you can see it better. Here we have a left justification of hi and hi again. As you can see where that exclamation point is, all the space here because it's left justified. But if I go back in here and I add the right justification, now it's right justified, as you can see here, and then of course the space being here, and now you can see that there's no space between the two exclamation points. So there you go. I hope that makes sense. It's definitely the most abstract of all the things you've learned so far, and very specialized, but I guess that's just part of it. So again, set W only affects the next value to be displayed. However, left and right, once you invoke it, all values that you see out for the rest of your program will be left justified or will be right justified until you change it again. And by default, it's right, okay? So those are big differences. So remember that. Otherwise, you may not want to do that for the rest of your program, and you're confused why everything is right justified all of a sudden, or why everything is left justified all of a sudden. So, yeah. Another thing is, right now, the empty spaces on our justification, so like all these things are just empty, are like spaces, right? Which is typically what you want to do because it looks nice. But you can also set it to fill with whatever you want. So suppose that you want to fill it, instead of with empty spaces, you want to fill it with a bunch of little asterisks, just because, you know, why not kind of thing, okay? So what you can do for that is you can call your function that is now going to be known as set fill, and it takes a parameter, and that parameter is going to be the character that you want to use instead of space. Okay, the default is of course a blank, which is just, I mean, like if you did this, nothing would happen. This would literally do the same thing because it's just a default. In fact, why call the function in the first place, right? But if you put instead of this something else, because I don't know, you want it to look cool like that, then you can see that it has replaced, it's still the same output. You can see right here, like before and after, but it has replaced all of the empty spots between the columns here with asterisks. So it replaced them here, here, and here, as you can see there, right? Also notice that just like left and right justification, once you set the fill to something else, it will remain like that until the end of the program. Yet again, if you want to reset it afterwards, so let's say I want to reset it before the high again, then you got to go in there and call set fill again and set it back to the original, which was this, or set it to something else. I mean, actually here, let's just put question marks instead. Now we got asterisk here, nothing here because it was big enough, but we got an asterisk there, asterisk and question mark. We want to set it back to default, switch that to a blank, and now it's set back to default on that. So that's pretty much how set fill works. It's sort of a combination of these functions. Finally, the last one that I want to show you is the one that is used to define the amount of decimal digits after a number. Okay, so oh man, that's like a mess at this point. Let's get rid of the set fill. Just set it to space, and let's see what we're working with here. Okay, let's switch the net income to a double. And let's make it very precise. Let's do 120.333345 like that. Okay? And let's set the float to be 4999999 like that. Okay? Yeah. And then maybe set the set the width to 20 for those. And let's get rid of this line. Okay, so all right, that looks good. Okay, yeah. So right now, by default, the system is only giving me 3 digits for the first one and 1 digit for the second one, right? But this being a tax statement, I care about 2 digits, right? Because that's what the tax man says. He wants it to the penny, no less, no more. All right, so that's what we're gonna go with. So for that, you're gonna use yet another function, and this one is called set precision. However, it turns out that you need actually a combination of things. Yeah. So you need both. You need to do this fixed thing and then set precision. Otherwise, it doesn't work. There we go. Okay. So, in fact, I think it doesn't work. But here, I want to double check. No, I compiled. Oh, I see. So if you don't do fixed, it tries to go with some scientific notation stuff like that, 10 to the 2.5 times 10 to the 5th power or whatever. Yeah. So I think that's what happens. Yeah. So then if you do fixed, then it actually doesn't do that scientific notation crap, and it just gives us the numbers, right? So yeah. Okay, that's what fixed does. I had a note here saying you have to use fixed, but I couldn't remember what it was. Now I do. I will forget next time I teach the class probably, but hey, now I do. And that is, if you don't put fixed, it still just keeps two values. Like you can see here, it kept two values, but then for the rest of the stuff, it just went with scientific notation. And hey, if you're doing math, I guess that's okay if that's what you're trying to go with. But if what you were trying to do is actually just print out that many decimal digits, then you put the word fixed in front of the set precision, and then it works. And by the way, set precision only works for floats and doubles. It doesn't work for an integer because it has no decimal digits already, okay? So there's no point in even using it for that. That's why I switched to the float and double. As you can see, setting precision to that. And also, here's the thing. This actually works correctly with rounding. So remember the thing with like integer division where it just chops off the decimal digit, and you know it could be like 4.999, but it still gives you 4, and then you know it just chops it off. With set precision, it actually does proper rounding. Notice that I gave it the values of here 120.333. It actually left it at 33, so it rounded down as it should because the 3 rounds down. However, on this one, I did this intentionally actually, the 4.9 or sorry 0.4999, it rounds up to 50. So the rounding is working as it should. So that's kind of good because we want to make sure we don't get attacked by the tax man. So, yep. If you want to unset the fixed thing for some reason, so like I said, you want to just undo the things that you did, you know, like mistakes were made. I want to bring it back because as you can see, set precision actually changes it forever, right? So like it's now printing 0.2 all over. Now I can switch it at any time to print out like a different amount. So like suppose that for the gross income, for some reason I want to print out just to the nearest dollar. Yeah, let's do dollar. Why not? Actually, I do believe in taxes. You don't put pennies. They tell you to round up, I think, or just round in general. So I can do something like that. And see, as you can see now, oh, I see why. Ooh, this kind of, I don't know how the taxman will feel about this. I guess it's okay, but because the value was 2.4999, technically it's going to look at the 4 and that rounds down. So this is correct. I mean, you would round down. You would even though it looks like you would want to round up, you don't, because it's anything that's 5 or greater, not less than. So yeah, so that's why this actually rounded down. So this is actually the best case scenario for us to not have to pay those 49 cents to the tax man. So yeah. So if for some reason you want to undo the fixed thing, I guess as I was saying. So if you want to just cancel out this precision thing. So let me just copy this over again one more time. So right now, of course, it's just printing out the same thing. Let's turn off. Of course, this is not doing anything because we already set it to that. So let's just get rid of all of that. So right now, that should print the same line twice. Okay. So in here, we can call out a little weird function that is, I think you don't even call it here. I think you can do it like this. Let me just try this and see what happens. Onset F. This one I have written down. Fix. There's a lot of nasty things. But hey, look, there's that scope resolution operator thing we were just talking about the other day. Well, not the other day, actually. The other hour, because it was literally like an hour ago. So that unfixed it. So that removed the fixed part. Now for the set precision, how do I get rid of that? Let's see. Cout.on unset iOS : let's see what we can do here. There's fixed. We need something with that says like set precision. Precision. Yeah, maybe that one works. I don't know. We got an error. No matching function call for precision. Was this a function itself, maybe? And then the precision value. Okay, so let's just not put any parameter and see. Okay, so what happens if we just set this to 2, I guess, here? But that's just the same thing as set precision. Yeah, I'm not sure. I'm not actually sure. By the way, what I did there is I tried to use the autofill to kind of give me the possible options that the library has to run things. But I'm not sure how you can unset it back to whatever the default is. What is the default? I'm not sure. Let's try to check on Google. How to unset precision in C++. There's a explanation of how to set it, but So apparently you can switch also. I wonder if that works. Let's try that. So if we comment this one out, and instead of saying fixed, we said scientific. Apparently that'll do the same thing as that weird nasty line. Ah, yeah, cool. So that's cool. So if you don't want to know what this, in fact, let's just forget about that line because there's a lot of magic happening there that I don't want to talk about. Let's just use the word scientific. That will switch it back to scientific. The question still remains: how do we unset the precision? I don't know. I don't know. I mean, if I knew what the default amount was, I could just switch it back. Is it STDCI precision N? I think I tried that, but it didn't let me do anything. But the question is, how do we set it back to a default? I mean, I can call set precision again, and I can set it to a specific number. But what if I just want to completely disable it once I've set it? I mean, you don't ever have to do this in an assignment or anything like that. Like, you don't have to set it, unset it. But, you know, I'm kind of curious now. I don't know. There's all talk about how to set them, but there's no talk about how to unset them. Yeah, there's a bunch of explanations on how to set it, but can't find anything off the top of my head, so I'll have to check later and I'll let you guys know in Discord. But I guess they're kind of assuming that if you set it to something, then you probably want to keep changing the setting depending on what you need. And you could. Like, I could switch. You saw here, I switched it from 2 to 0. I could keep switching it as many times as I want. But I guess I can never switch back to the automatic way. Maybe by defining a new variable and saving that. Set default back. Oh, okay. Stack Overflow. Let me check that and read that. Let's see. You can get precision before you change it. Oh yeah, somebody mentioned this at some point in my life. You can save it and then switch it back. Yeah, this makes sense. So yeah, this is the way. So Marty is right. See, he's teaching 135 in the fall, so that's a good sign that he knows this. You know, when 135 comes, I hope this comes up and then he remembers it. But yeah. So I don't know for what, but the idea of sort of backing up something and then using it back, I think it was with this example, but with something in 135, it came relevant. So yeah. So the basic idea here is this. So just like Maddie said, we're going to declare a variable, and now it's not just any kind of variable; it's a special variable. Don't worry about that part, but it says we're going to set it to that, and then we're going to copy the current precision there. Okay, and actually, I'm going to. I'm curious to see if it prints out anything, so I'm going to try to print it out, see what happens. Let's see what it's set to, what that number is. Ah, okay, so there's no overload for that. So you can't just print it out. Yeah, okay, that's okay. Wait, what? Oh, I see. I have random code here that I shouldn't have. There we go. So it's 6. So it's originally set to 6. Okay? Dang it. It's originally set to 6. So that's pretty much what it's kind of saving there. All right? So it's saving as 6. So anyways, we save it to this variable SS, and then we do a bunch of crap to it. We mess it up in a way, and then now we want to switch it back. So how do we switch it back? Well, we call that one the one function that we saw earlier, that CS precision thing. Well, we saw the CS on what was it, like set F or whatever. So in here we're gonna go back and do precision, and then we can just pass it the SS, which should set it to 6 again. And so now, if we go ahead and recopy this line here, hold on, get rid of this stuff too. So I guess I do the cout dot. You don't need the std part, by the way, because we're using namespace std, so that makes it simpler to see. We can leave the scientific here actually. Scientific, but do this set f fixed. I think it was. What was the line of code? Oh, unset. Yeah. So unset fixed like that. Cout.onset f fixed. I guess because this is not this part, because it's not std, namespace std. Yeah, okay. We're almost there, guys. We're almost there. Could you scroll down a bit? Yeah. Here you go. Don't worry, I was gonna show you once we finally get this running. Scientific. I see it's misspelled. Okay, there we go. All right. Dang, we're almost there, but get rid of this one. Unset science. I guess in this case we're gonna unset scientific because we switched it to that. Okay, there we go. Finally, we got it going. So now I can actually go and explain what I just did here. So, okay. So as you can see, we were messing around with precision. We had it to 2. We had it to 0. Then we switched to the scientific mode. And then we want to unset scientific mode and set the precision back to default. So here's what we do for that, okay? So what we do for that is before we do anything to the code, we're going to back up what the default precision is set to, which happens to be 6. So the way we do that is, as Matty provided with the Stack Overflow link, is you call cout. We can actually get rid of the std part here because we have using namespace std, so we don't need these. So I guess I'll get rid of them just to not scare you with confusing code. So like that. So we create a stream size variable. That's okay. Don't feel bad if you know what that is. Just for now, you know that you do that. And then you copy out cout precision. Now notice the dot there. That's the member access operator. Yet again, we haven't talked about much about that. Although I did mention by name. When we talk about structs, what it means is this thing is an object, and that object has a bunch of functions and variables in it. And so in this case, we're accessing one of the functions of cout. And so that is the precision one. And that just returns to you basically what the precision is set currently as, which the default is being set because we haven't messed with it. So we basically back it up. And then I even went ahead and printed it out here, which printed out to 6, which you can see there, okay? After I backed it up, then I did all my messing with it. So first I set it to 2 so that I could print out the dollars and pennies. Then I set it to 0 so that it could print out dollars and rounding up and everything, rounding the correct way. I even went ahead and I made it into scientific format, and I printed out my income in scientific. But because I had it set to the precision of 0 in that sense, it just put a 2 to the 3rd power, 2 times 10 to the 3rd power. That's why you see just a 2 there. If I wanted to see it like all 4 digits here, then I would have to set the precision before I do that. So I could do like set precision to 4. And now the scientific notation should look much better or more accurate. Yeah, so like now it looks more accurate, right? In fact, it actually the precision there indicates the number after the dot. So I guess it's always going to print out 1 digit. So you can see now it's printing out 4 digits there in accuracy, and then it says times 10 to the 3rd power. Okay, so then finally we want to just go back to normal. So the first thing we got to do is we got to unset the fixed or the scientific mode. So if it was the fixed one, I could do cout unset iOS colons, which is scope res operator, and then fixed. But because I switched it to scientific, then I'm going to put scientific here. Now, yeah, this is confusing code. No, I'm not going to test you on that. This is for your own benefit, at least for this piece. I am going to test you on this kind of stuff, but not on unsetting it. But I still think it's good information to know. So you call this unset function here, and then you unset the scientific mode because that's the last one that you did. If you had only done the fixed, then you do unset fixed. that would just remove the scientific part of it, but it would still leave the, in fact, here, let's print it out so you can see what it would look like. Which one is it? Here, let's put, I'll add there so I know which one it is. Huh, interesting. How now it's printed, but before it hadn't. I don't know why, that was, I guess I forgot to save. Yeah, that must have been it, I forgot to save. But anyway, so I turned off the scientific mode, so you can see I go back to sort of how I had it before here, but it's still not printing out the decimals. So then I gotta bring back the precision to fix it. And then I'm gonna use the cout precision, and then I'm gonna pass it back that variable that I created initially, kind of like backing it up. And then now I run yet again the gross income, and now it comes back the way that it would have come out if I hadn't done anything, which was just one digit. The same concept of backing up a variable applies for anything. Imagine that at the beginning of the program, the user enters a 5. And you want to save that somewhere. And then you do a bunch of computations and whatnot, but at the end of the program, you still want to know what the user entered. So you back it up in the variable, and then you refer it later on. So this idea of sort of copying things, then doing stuff, and then coming back and resetting them is a very normal thing to do in programming, okay? So yeah, that pretty much wraps up the formatting output stuff, or section, chapter. Now I think we're really done with chapter 3. Okay? Questions? This is all the content I wanted to cover, but since we have time, I'm not gonna cover loops, but I'm gonna cover a little bit of Linux redirection or command line arguments. Yeah, actually, I'm gonna cover command line arguments because I can do those quickly. But anyways, no questions? Anything? All right. In that case, I'm going to cover another way that you can do some input that's kind of interesting, and it's used for a lot of things, or at least it used to be. So back in the day, and then by that I mean like early 90s, late 80s, when computers were just terminal based, and because here's the thing, this formatting output that I'm showing you, I think it's the one part of the course that I think it's relatively useless to know. And I'm not afraid to say that, because here's the thing. Formatting output that I'm showing you, this, set precision and right and left justification, this is all just for working on a terminal, okay? But how often do you see users interact with a terminal in like the modern world? Never. You don't ever see that. The only time you see somebody interacting with a terminal is when they're connecting to a server where there's no user interface, like GUI, graphical user interface. Most of the time, the user interfaces are much prettier than just a terminal, because we've kind of transcended from those days to better, because we have more memory, more space. We can do a lot prettier things, right? And so you're never going to use this stuff. You're never going to use this stuff ever. Unless you're working on trying to make a terminal look pretty, you will never use this stuff. So that's why I think it's kind of useless. But hey, it's a good application about how to use some functions and get more practice in coding in general. So there's that much. But hey, it's part of the curriculum, so that's what I'm showing it to you. But yeah, back in the day, in the late 90s or 80s, when things were terminal based, it was very useful because everybody was reading a terminal, and you don't want to be an eyesore. You wanted to make things look pretty, right? Another thing is, when you were running a program on a terminal, if you wanted to run it with specific settings, what you would normally do is you would say something like, let's say you're executing a program. What's a good example? Oh God, I'm kind of trying to think of something. Yeah, okay, so let's say you want to use manual. What manual page do you want? Okay, that's head. dash help. Okay, so if you're using the terminal here, as you can see, by the way, this is iomanip, for example, or something like nicely formatted output, right? Because I'm working on a terminal. So this is the kind of stuff that you would use io manipulator for. But anyways, when you were running a program back in the day, you would write the name of the program, and then you would write a bunch of text afterwards. And that text afterwards were the arguments that the program needed or were optionally needed to do a couple of things. And so, for example, if I go ahead and run the head command, what that does is it prints the top of a program or a text file. So like if I do head conditionals, it prints out the first few, I think 10 lines, 2, 4, 6, 8, 10, or 11. I don't know, the first some lines of the file. Of course, the file itself has more than that. I can use the more command for that. You can see it has a lot more. But head is useful for basically kind of peeking into the opening of a file just to see what it has, okay? So that's what the head command is. But the head command can do a lot more things than just that. And that's with the power of the arguments that you can give it. So one very popular argument that a lot of programs have on a terminal is the help argument. So you can do dash, well, if you saw I did dash h because some programs that works, but in this case it did it. But the other one that usually works is 2 dashes and the word help. And that, instead of running the actual head command on a file, is going to give me all of the possible arguments that I can give it. And if I don't want this, technically, actually, when I do something like head and then I do the conditionals like that, when I'm doing that, technically the word conditionals is an argument, because I'm saying run the program head on the file conditionals, and which basically looks at the file, gets the first 10 lines or how much, and then shows them in the terminal, okay? So we call conditionals a command line argument, just like head dash help is also a command line argument. And the command line arguments, the order that we give them is basically the order that you're going to name them. And always the first argument is the name of the executable. So in this case, head. If I'm just going to execute a program like ./a.out, technically my first command and argument is just the ./a.out, which is the name of the executable, right? But in this case, I don't have anything after that. I could put like potato head hi, and it still runs the same program. It just ignores them, because when I wrote this little program that we were using, we didn't handle any sort of command argument, so it just kind of ignores them. However, with the head, it has a couple of things that you can actually do. For example, the very useful one is the -n. So I can do head, and then I can do -5. I think it goes in this order. Let me try that. Yeah, okay. So I can do head dash a number and then the name of the file. And what this does is it prints out that many number of lines. So -3 is going to print out just 3 lines. -5, as I had it, it's going to print out 5 lines. Now you're like, hey, there's only 3 lines here. No. The white space here is also technically a line. Like, that's actually a line. Okay, it's just nothing in that line, but it's counted as a line. I could also do like a really big number here, which is just going to print out the entire program. But if I had a really big file here, like 10,000 lines of text in here, then it only would print out the first 200 lines of text. So that's a very useful feature to have in the head command, because I can use it to analyze text, right? We call that a command line argument, because now we have technically 3 command line arguments. The first one is the name of the file, the executable, which is head. The second one is a dash with a number, which represents how many lines I want to print. And the third one is the name of the file that I'm going to be doing the printing from. And there can be more command line arguments here. Again, I can use the help to kind of, you can do this with most Linux commands to find more information about them. Like, I think I even do that with like cd. Yeah, cd, and it gives me all the instructions. So in this case, though, we are looking at the head command, and it tells me that there's a -c, which prints the first number of bytes of each file. with deleting dash. So let's try that. I guess let's try to do head dash. How do I actually do that? So I can, oh, I can also do dash n5. Does that work? Yeah. Okay. So if I don't want to specify the number directly here, I can do dash n and then actually list the number next and then the file name. So that will do the same thing as this. Oh, hold on. I put a rogue quote. Okay. But let's try the C one and see. So what does it mean to print out the first 3 bytes? It just literally printed out the first 3 characters. Okay, that's because one character is actually held in 1 byte. So really it's printing out by character more than by byte. But byte is the correct term for that. So if I say 10, it's going to print out the first 10 letters. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so that's pretty cool too. So I want to print out just the first 200 characters or 200 letters. Oh, it glitched out on me. Hold on. Head dash C 200 conditional. And as you can see, it prints out the first 200 characters. So command line arguments are pretty useful in the terminal to not just have a, again, it's not just, you know, you're given this head command, which is really cool, prints out the first 10 lines of text, but somebody eventually is going to be like, man, I really wish I could print out only the first 9 or I could print out 11. And so that's why the people who created the help command, or sorry, the head command, went ahead and added features to the program. Now, could they have made it interactive, like how you have your quiz, or like last class where I run head and it says, how many lines would you like to print? What file would you like to run? Yeah, you could do that, but that's more effort for me as a user. I want to just be able to write a line quickly here that says like head -n10 and then the file name, and I know that the -n is the number of lines and the file name is the last thing that I give in. I know all these things. It's much faster than having a menu that asks me a bunch of things, right? This is like quick and dirty, get it done, good to go. I could even write a program that would generate the string that I need to run on head and script it. That's basically running a little script, okay? Or, you know, it could be a virus too. But yeah. What are the things you have in here? There's a quiet mode, which never prints the headers of a file. Verbose prints over the headers of a file. I don't know. Line delimiter is null. So there's a bunch of little things that you can do here. I guess another very popular one for any program is the dash version. That usually tells you the version of a program that you're running for anything. In this case, it says it's version 8.25. And it also tells me some copyright. There's no warranty. Use at your own risk kind of thing. So those are command line arguments. And so the question is, how do we actually do that in C++? How do we can actually use command line arguments in our programs? And it turns out that it's actually not that hard. Let's throw it in a, let's do it in a, no, this is perfect. We'll do it in here, in the command line argument. We'll do it in a new file still, but we'll use the same code. The command line argument is going to specify the precision of the decimals. How about that? Can we do that in 5 minutes? We shall try. We'll call this a tax.cpp. We got our code in there. G++, tax.cpp. Okay, and then let's get rid of a bunch of stuff until here. We don't need to back up this, whatever. Okay, so there we go. Let's get rid of the set fill. Let's get rid of the set precision. Let's create a variable called int decimal digits. Okay, we'll set it initially to be 0. And then here we can call decimal digits instead of actually passing it a literal. Okay, so right now it's 0, right? What I want to do is, when I run this program, I want my command line argument to specify a number. And that number is going to represent how many decimal digits I want to print, okay? And so, what you have to do is, you're going to manipulate this line that's the main line. In here, you're gonna put int argc. Actually, it doesn't matter the names, but these are the pedantic names: int argc and car asterisk argv. Okay, let's make sure I got this right. Yeah, and now all I gotta do is when I create int decimal. Here, I'll do it in a separate line. Decimal digits gets argv1. Now this may ask me to convert it to a string. Yeah, okay, so, or sorry, to an int. A to I. Let me try that. This is I think this function will do it, otherwise I have to use more magic. Yeah, okay, so that's part of include cstd_lib. Let's try that one. Yeah, okay. Yes. Oh, segmentation fault. Oh, okay. So I can get to talk to you about a segmentation fault. When this happens in your program, it is a short way of telling you that your program crashed. You know, like when you're running a program and the computer freezes and it closes the program, that's what a segmentation fault is. You don't usually see this until in 135 because you don't actually do something that will create one, except now I did. So it's a good thing to see. If that happens, it means your program crashed somewhere, you don't know where. You can use a debugger to find out. That's a whole different lecture. In this case, it crashed because of the conversion here, because it tried to read this. So we're going to do something that we... I know why. Because I gave it no argument, that's why. So let's use our if statement real fast. If argc is equal to 1, then we want to run that. Otherwise, still crash. If argc is equal to 2, my bad. No crash. Okay, but now the real question is, will this work if I put a 2 here? Yes, it worked. Okay, great. So we got 3 minutes still, so we're on track to actually finish this. Okay, good. So the segmentation fault, we'll talk about that on a different day, but that means your program crashes if you ever see that. It sucks, but so it is the life of a programmer. So, okay, so we went ahead and created 2 parameters in our main function. The first one is an integer and the second one is a car, but it's not just any kind of car. It's actually an array of cars. Again, we haven't really talked about arrays, so for now, just know that it's a list of characters. So it's a bunch of them, kind of like a string, but not really, okay? And so the first argc is an integer, and that when you run your program, that argc variable holds the number of arguments that your program was given when you executed it. So by default, if you don't give anything, if you use ./a.out, it's going to contain the value of 1. Okay? In fact, I could actually see out argc and it would show 1. If I pass it a one word after, so each word is separated by a space. So in this case, I pass it the number 2 here. I'll show you. If I pass it this number 2 here, in this case, this is the second argument. But here's the thing. The counter starts from 0, but the amount of them is correct. So now we have 2 arguments. So you may ask yourself, why did I do if argc equals 2 to this? Because I am checking in my if statement how many arguments I have. And only if I have 2 do I want to mess with this. If not, then I want to just ignore the arguments given and just stick to my original value of 0. So I had 0 for the decimal digits. So that's why if I run it without any arguments except for just the name of the program, it just sticks to 0 decimals. Whereas if I run it with a 2, it prints out with 2 decimals. That's because in that case, the argument count was equal to 2. And so now I just need to update the decimal digits to whatever this number is here. How do I do that? This thing is an array. Arrays start from 0. And technically 1 is actually the second item in the array. That will be explained later. But this line of code here is going to extract the 2 from the arguments that were run when the program was executed. The a to I is a function that's going to convert alpha to integer, because the 2 here is not actually a number, it's a character. So to convert it to an actual integer, a number, we need to run that function. And then it gets stored in decimal digits. Finally, that decimal digits now can contain the number that is going to be called set precision on, which is a 2. So just for shows, we can put a 5 here. you can see there, now it prints up to 5 decimal digits. I could print up to 10. Eventually, I'm going to run out of space because of the justification. So things get shifted there because now I run it with 152. So there you go, just right as the class ended. That's command line arguments. We'll revisit command line arguments again when we actually talk about arrays because it'll make a little bit more sense. Okay? So, but I still wanted to bring them up since we had a little bit of time. Next time we were going to be talking about batch processing and Linux redirection, or we'll talk about loops. I'll have to make up my mind on which one we do first. I have to look at the assignments and see which one we need to cover first. Okay? But that's it. If there are any questions, then you feel free to ask them now. Otherwise, then that's the end of the lecture. We covered a lot today, actually. Pretty happy about what we covered. So yeah, anything? My dog got to hang out with me, I think, the entire lecture here, too. All right, you're welcome. I guess I'll see you guys tomorrow then. Yes, she's a very cute puppy. All right, well, this video should be up on YouTube in HD around 3 p.m. So if you need to rewatch it, if not, you can just watch it on Twitch immediately after. So cool then. See you guys.